Hello and welcome to this video, which is going to be some examples of combining the mean and the standard deviations with constants, multiplications, and things of that nature. Okay, so let's look at adding and subtracting. So let's look about the video we did 2 ago, which would which it was the payout. So it was x was the payout. So if I had 0 was 997 over 1,000. I'll try to hurry up and do this. Here, I'll pause and then I'll just write it up there. Back, and let's say we charged $50. We charged everybody $50 to buy the policy. Okay, $50. So, and I can't say this is maybe per year, or if it could be a month, but this means one person is going to die a month and two people are going to be die a month. So we'll just do it as a year. So it costs $50 to buy this policy. Let me make this look a little better. $50 to buy the policy. So so then the profit for the company. Now remember, this is per policy, per person. Profit for company per policy is $30. Okay, so let's say I want to lower this. I want to lower this to 45. I don't want to charge them 50. Okay, I don't want to charge them 50. So the expected value of, I'll call this, so the expected profit is 30. But what happens if you lower this by $5? So I'm only going to charge $45. So what's the new profit? The new profit would go down by $5. Okay, the new profit would go down by $5. Okay, so let me just write this out. New profit, or let me do it like this. New profit equals this will make sense right now. The new profit equals the old profit minus $5. Okay, so if I said what's the probability of the new profit, you see how this works? So that's the expected value of, I'm just substituting. See, NP equals P minus 5, so this would be P minus 5. So that's the expected value of the old profit, which was $30 minus 5, which would be $25. So I just showed you how to use that formula. Okay, I'm just naming these things, and it is good to kind of get it good at this notation. Okay, so I'll just write here new profit in case you don't know what I'm doing. Take a little key. But how about the standard deviation? Okay, how about the standard deviation? Well, first of all, we don't work with standard deviations, right? We work with variance. So the variance of the new profit, let me write the variance of, this is 387 squared. Okay, so this would just be all in money. This wouldn't be, the variance isn't really affected by all this stuff here. So let me get rid of this. So the amount of variability will be the same thing. The variance of, let me just change this to x. Okay, so x minus 5 equals the variance of x, 387 squared, and then to change it into standard deviation, so standard deviation of x equals the square root of the variance of x. Follow me along. That's an equality. That's what that means, is 387. So decreasing how much you charge by $5 didn't change my standard deviation. My standard deviation stayed the same. Okay? So you're not going to get many like that. You're not going to get. So if you're sitting there and you're not too sure about what I just did, don't necessarily worry about it. This is where you have to be careful, because in algebra we know that this is true, right? Okay, so if you have 3x's, well, you know this is 3x, correct? In algebra? That's a yes. But this is not true in statistics. It's not true in statistics, okay? It's true for means, not for variance / standard deviation. Okay? X plus x plus x is not equal to 3x. Those rules don't apply. Okay? It's really two different. If you looked at the last video, it's two different formulas, because watch how this works. Okay? And the formula, 3x would be the variance of 3x. So real quick, do you remember? You have to take this 3 out and square it. Take that 3 out and square it, which you'll get the variance of x. Okay? But what's the variance of x plus x plus x? Okay? Now if that's the case, these are just that's just the variance of x plus the variance of x plus the variance of x. How many variance of x's do you have? 1, 2, 3. They're all the same, so that's equal to 3 times the variance of x. So you tell me, which one of these numbers is going to be larger? Which one of these variances is going to be larger? Because it's not the same. One's 9. One is 9 times the variance of x, and the other one is 3 times the variance of x. So which one has more variance? Does 3x have more variance, or x plus x plus x? This has more variance. Now variance in this is risk. Variance is more risk. It's how much, the bigger variance, the bigger standard deviation. The bigger the standard deviation, the more risk you have. The higher it could be, to the right, or the lower it could be to the left. This here is smaller, so this lowers risk. So if you look at it, like, what's the difference between these two? Let's talk about the policy. What's the difference between the variance of 3x and x plus x plus x? Well, this would be increasing these guys right here. You're increasing your premiums by 3. You're increasing your x's by 3 times. This would be, instead of having one person, or this is one person, this is a second person, and this is a third person. You see? So what does more people do to your risk? You should know this. This is common sense. More people lower your risk, which is your variability. Okay? So we'll do an example like that, and we'll change it to like 5. So let's say you increase your premiums by 5 times. Okay, so what's the expected value of, now I'm doing a multiplication. You increase your premiums by 5, so that's the expected value of 5x, and I'm looking for the variance of 5x. Okay, So in this case, I could pull the 5 out, and that's going to be times the expected value of x, which is 5 times 20, which I could expect to make $100 per policy if I increase these guys by multiple of 5. I'm going to say that again. If I increase the payouts by times 5, then I expect to make $100 per policy. This is per policy. Per policy. Okay? Now what about this variance of 5x? The formula says take the 5 out, square it, times the variance of x. So this is going to be 25 times 387, okay, squared, because this is variance. This is standard deviation. So to go to variance, I square it. But to turn it back into standard deviation, I take the square root of 25 times 387 squared, which is just equal to 5, whatever 5 times 387. Okay, 19, is it 1935? Probably not, but let's do a quick thing. 387 times 5. Hey, it's right. Okay, so that's your standard deviation. So your standard deviation, your new mu of 5x equals $100, and the standard deviation of 5x equals 1935, and this is in dollar signs. Okay, so now let's look at the other case. This would be increasing the policy payouts by 5, multiple of 5, and this would be getting 5 people. Okay, so 5 people would be the expected value of x1 plus x2 plus x3 plus x4 plus x5. Each one is a person. So the formula tells me expected value of x1 plus the expected value of x2 plus all the way to the expected value of x5. Okay, so what's the expected value for every single person? How much are they supposed to pay you out for every single person? Okay, they're supposed to pay you 20. So that's 20 there, $20 there, and I'm adding. And how many x's do I have? You have 5. So the expected value of all these people is $100. Hence, it's true for means, but not for variance. Okay, so based on what I said over there, you should know. Okay, the goal is to find the standard deviation of all these people. How much variance am I going to have if I get 5 people to buy this policy? Okay, how much standard deviation am I going to have if I get 5 different people to buy this policy versus increasing the premiums for times 5 and only having it per policy? Okay, so when we deal with standard deviations, we want to find the variance of all these. x1 plus x2 plus x5. Okay, so these are all pluses, and it doesn't matter if it's plus or minus, we always plus them. So that's the variance of x1, and I'm just using the formulas from the last video. x2, I'm going to go all the way to the variance of x5. So what's the variance of everybody? Okay, the variance is, here's the standard deviation. So to turn into variance, you square it. So it's 387 squared plus 387 squared. And how many of these am I going to have? How many 387s do I have? 5, because I have 5 variances. So this is going to be 5 times 387 squared. Okay, so to find this, okay, now to find the standard deviation, I have to take the square root of this. Okay, so I have to take the square root of this. So let me get rid of that equal sign. So the standard deviation of x1 through x5 equals the square root of 5 times 387 squared. Okay, so let me pull up my nicer calculator. I'm not sure if my other one has square roots or not, but second square root 5 times 387 squared. Looks good. 865. Write it over here. $865. So which one had more variance? Which one had less variance? That had less variance when I took 5 people. If I increase the premiums by 5, okay, my variance is really big. It's almost $2,000. Okay, so I'm expected to pay out 100, but it wouldn't be out of the ordinary to pay out 2,000. Do y'all see that? Per policy, because it's one standard deviation away. I'm going to draw an arrow. Hopefully you're not getting confused. I know I'm going way too long. So you're expected to pay $100 if I increase these guys by 5, but the standard deviation is almost 2,000. So it wouldn't be out of the ordinary to have to pay $2,000. Okay, we're here. Okay, the standard deviation is much, much lower. So you're lowering your risk. You're lowering your risk. And the more people you go, your risk reward gets better because you're going to charge money. This is how much you have to pay. Okay, so of course, the more people that you get, the more people you'll have to pay. But don't forget, they're paying for this too. So you're getting a profit for every person. Okay, so if you charge 50, you're making 150 profit. If you charge 50 per policy, you see 50 here, 50 here. Okay, 150. This is how much you're making. But look at this is how much it could go up to. So per person. So it actually gets better with more people. So that's an example. I may do one more. I'm not sure because these are kind of running long and you're probably bored to death. But it is kind of fun when you really understand it. So thanks for watching.